Hello and welcome to another class time session. Kamei and I are excited to delve yet again into the language of the universe.
You're referring to math, right?
Of course I am.
Okay, just wanted to make sure. So our topic for today is problem solving in number theory and computation. Let's get right to it.
I agree.
So let's take a look at our objectives for today.
All right. Understanding problem solving strategies,
And using problem solving strategies in computation and number theory. Let's look at this scenario.
all right.
Junior wants to start a backyard chicken coop farm. He has $1,252.50. He needs to buy trays and each tray costs $50. It costs $752.50 for a taxi to take the trays to his farm. How many trays can Junior buy? Guess what, Tamika? Junior have a problem.
Well, at least him have some money, so let's see if we
But him still have a problem because he has money, yes.
needs the trays, because without the trays the farm not gonna work. So he has to figure out we need to figure out how many trays he can buy.
But in figuring out how many trays he can buy, don't we need to know some things?
Well, they told us the cost of the tray. I know how much money he has. That's all I need to know.
No, man, but I think, we know he has a problem. We need to understand what the problem is. So in understanding what the problem is here, you would have rightly said he has some money.
He has some money.
So we
and
know
he
he
knows
has
how
some
much
money.
to buy, how much to pay for
Great.
each tray.
Right, so he has some money. He needs to buy some trays. And guess what? He knows how much, or he knows the cost of each tray.
Most definitely.
What else he knows? Look again at the scenario, man.
You
What
said
else
I
he
need to
knows?
understand. There's another figure in there that are probably all right. It costs $752.50 for a taxi to. He needs to get the trays to the farm.
Good.
So that's a part of understanding his problem. Okay, so he has to make sure that he pays attention to all the information that he needs to in order to buy these trays.
So after he would have understood his problem, then he would have just listed
He
us.
needs to start planning how I'm going to get these trays.
So we need to figure it out,
Man,
don't
he needs
it?
to make a plan to figure out how he's going to start the coop by getting these trays. So he needs to buy the trays and get them to the farm. So he
Alright.
has to make a plan in order to figure this out.
And when he makes the plan, guess what is going to happen now? What will take place? So he understands that him have a problem, him plan it, then
He can work out this plan and end up with a solution, man.
good, so I'm going to solve the problem.
Of course, because after your plan, you can solve.
Great, and in him solving the problem, when he now knows that he needs so much trays
Or
to
him can
purchase.
afford so much trays.
Right,
'cause-
based on how much money he has.
Right.
Right. So based on how many trays he would have now ended up with, he would have realized, all right, as you rightly said, I can afford it, I can't afford it. But
So if he plans well, he can see the money that he will realize that the money he has can pay for X amount of trays and also the transportation costs, because he has to pay that taxi. So with understanding his problem, planning how I'm going to use his money, planning how to solve his problem, he can come up with a viable solution. And then at the end, before he even execute everything or after he figure out the solution, he can definitely check if everything works out.
if everything works
Yeah.
out. What you think we really looked at here? Because we started out with Junior having a what again?
He had a problem.
Great. So he had a
wanted
problem.
that chicken coop, and he had X amount of money. He had a
Alright.
specific amount of money to get some trays.
And so we're just going to put it now in writing. So here we know that we're looking at problem solving, and we would have spoken
yes.
about a process that entails in Junior having the problem and such. So here goes. So the problem solving process is a set of steps that are sufficiently general so that they can be applied to any problem in order to obtain a solution.
So before you even move on, when you say sufficiently general, what you mean? I can apply this not only to Juna's problem, but to any other problem I have.
Right. No, you're thinking. So to
Okay.
any other problem, because guess what? A problem is a problem.
Got you.
So in figuring out that problem, there's a process that takes place in really solving that problem.
Well, that makes sense.
Yes, and we would have spoken about the
course we
process, but we're just formalizing it because one, we realized that we had to understand the problem
Of course, we had
first.
to look at all the information that was given.
Great.
Uh-huh.
And in understanding the problem, we had to devise a plan.
We plan out something. We come up with some way to figure out how to solve that problem. So we made a plan.
Great. And then what else we did?
You implement the plan, man.
Good. And in implementing the plan, we know we have to solve it, don't
Right,
it?
we find a solution.
We're
Any way
going.
you want, term it.
Right. And then guess what? We can now check to
see
ensure
if-
that that plan that we came up with and we implemented that plan, that it does work.
Because guess what happens? Sometimes the plan don't work, you know. So you really have to go back and check and look back where you made that error and make a new plan.
All right. So since we would have spoken about Junior with his problem, we're
help
now
Junior.
going to take a look at everything. So we looked at the factors that he had.
We know he had $1,252.50 to buy the trays.
What else we knew?
Each trays cost $50.
Great. What else?
That this little cost here, he definitely can't take the trays on his back. He needs a taxi, which costs $752.50.
Great. So we have all of these factors that we know. So we know these factors from the problem.
So what you're saying, in knowing these, we now understand Juna's problem.
We need, before saying that we definitely understand, so we know what he has, but guess what? We need now to finalize that we understand the problem.
Yeah.
We need now to figure out what he needs, which we said already.
Right. He needs to figure out how many trays.
Right.
So we need to know what we are working towards. What is the problem that we have?
Nice. So in understanding the problem, we need to look at the factors that we have, and we also need to know what we need to find out.
Right.
So
What is
that's in the
required.
that's in the understanding process.
All right.
And we would have spoken about our plan.
After you understand, you can definitely plan.
You know what I'm thinking though about with the plan? The plan that I'm thinking, because if we know how much money he has,
Right.
we know that he needs some trays. We know that each tray costs $50. We also know he needs transportation, and there is money allotted for transportation. In this plan, I think maybe in solving it, we can maybe work it backward.
All right. So you're going to solve this by working backward. You can work backward to find the number of trays that can be bought.
Yeah, man, that's what I'm going to do. I'm going to work it backwards. I'm going to use what we have.
All right, make we discuss and see how that works then, no?
Yeah, man, I'm going to show you. So
Okay.
don't stress it, man. I'm going to show you. So look here now. So the first thing that we're going to do, we're going to separate the cost of the taxi by subtracting the cost of transportation. Guess
Makes
what?
sense.
From the money that he has.
So you can't order taxi till another time.
Not at all. So right here we would have done this. So we know that he originally had $1,252.50.
Right.
We also know that the taxi is $752.50. So we would have subtracted to know how much money we're working with now. So we have
$500 in all.
$500 in
And
all.
there I thought Juna could buy a whole heap of trays.
No, that's why we need to understand the problem, and that's why we need to figure out how we're going to solve the problem, and then we implement this plan that we have. So we know we have $500 working with now. So now we need to calculate how many trays can be purchased from the money left. Now, how would you calculate the cost of this? Tell me
Well,
now.
definitely. If you have $500 and you know each tray costs $50, it's simple, man. You divide 15 to 500. Or you can go and add 50 till you each 500, whichever way you want to do it. But
All right.
efficiently, I would divide 15 to 500.
Great, because we were told that each tray cost $50.
Right.
So in dividing my 500 by the $50, we know that how many tray Junior needs now.
He can only purchase 10 trays.
Great, good job.
10 trays. In
So we
fact,
know
kind of
it's
small, but all right.
10 trays. So what we realize happened? You realize that I told you what's my plan, how I'm going to figure out how many trays he needed. You remember what I said?
You said you're using the backward method. The backward way. Yes,
I want to work it backwards. So I'm using what we know to try and figure out what we need to find out. Right? All right. And now I'm going to check. So I want to show you that our solution that we would have arrived at is correct. So here we have, how can you show that your answer is correct? We're going to check it.
That's right, man.
And when checking it, we're going to know if our answer is reasonable as well. So let's take a look here. Okay. So we would have arrived at 10 trays. And we also know each tray, $50. So when you multiply the 10 trays that we got by the $50 for each tray, what did we get?
$500.
$500. And then let's look here now. So we know $500 for all the trays. Now the 10 trays that he needs. And tell me what
transportation cost would have been $752.50. So when you add those two figures, you'd have gotten exactly what Juna started out with. $1,252.50. So you're right.
We answer correct.
Simple something.
So we solve the problem. We solve Juna's problem. So now Junior can go to the farm store and buy him 10 trays. Just like that.
Exactly.
So in looking at this now, and remember I would have shared that I was working it backward, right? So now this is what is entailed in the working backward.
Okay.
So one, start with the end of a problem and work step by step, which is what we did, toward the beginning to get a solution.
Right.
Two, write down what you don't know and what you do know.
Makes sense.
Right. Three, write down each step as you get closer to the answer.
Okay.
And four, the last step, which we did, will verify that the solution works.
And we saw that it works. Everything added up and we're good to go.
Yeah, we were okay.
All right, so here we are. So what you said, problem solving. So when you are faced with a problem, we must first understand the problem. When we understand the problem, we may read the problem and maybe twice, identify the question or questions, circle what you know. That's understanding the problem. Then next, we plan. Choose a strategy that makes sense and works for you. Now, that first strategy, it worked for us this time, but it may not always work. So it's always okay to make another plan. Then make an estimate. What do you think the answer may look like?
Might be yes.
Right. Solve, try your strategy, show all your work, label and circle your answer. And then, of course, the last thing is to check. Explain and justify your answer. Decide if your answer is reasonable. And we pretty much did all of that.
Come on, we did all that. And when we're thinking about all this that we have here, understand, plan, solve, check, we are again looking at the problem solving process.
There you go.
There's a process that we go through and we know we definitely have to understand the problem. So I want to know if you're paying attention. So guess what is going to happen now?
I know you're going to just give me something else to do.
Yeah, man, because I want to know how you're going to solve this problem.
All right.
So here's your problem. So Junior went to the supermarket.
Joel.
Oh yes,
Juna was the farm.
Yes, so Joel now went to the supermarket to purchase peanut butter for his mother.
Okay.
He saw 2 jars of peanut butter of the same brand.
That's right.
And there's your photo of the peanut butters, right?
The brand is peanut butter.
Right. This is what I want you to tell me now. He wants to know which of the jars shown is the better buy.
Well, power is okay. All right. So we have the small jar there, which is 150 grams of peanut butter for $2.14. And we have a 400-gram jar for $6.50. All right. What is the better buy? All right. He's going to have to figure out how much he's paying for a gram. Or him can figure out, can he ask himself how many of the small one can fit in the big one?
Well, him can ask himself that question for real, you know, but when him go in the supermarket, him can go put each of the small ones, the 150 gram into the 400 gram
He's going to
jar.
estimate.
All right, so now
he
you're
needs to
talking.
understand what the cost and the cost in relation to the amount of peanut butter.
No, you're thinking, man,
Yeah.
you're getting somewhere
You
good.
need to understand how much, 150 to 2. You can do a little ratio thing, 150 to $2.14 and 400 to $6.50, and see where I'm going with that.
All right. So in what you are saying now then, that he understands that it's the same brand. It's not that one brand is, maybe
Tastes
of
better, tastes sweeter.
it's the same brand. But it's just that, hey, one costs $2.14, one costs $6.50, right?
But one bigger, so we know, maybe just buy the bigger one.
You don't just buy the bigger one? Well, that is what you just would do, but Junior want to figure out which one is the better buy. And
Which makes sense.
Yes, it does make sense. So what you would have shared earlier about him trying to figure out how much for each gram
Right.
in each of the peanut butter jars. We can try and take it from that angle.
All right.
So we would look at how much is it for each gram in jar A, how much it is for each gram in jar B. So let's take a look here because I had written it down. So let's look here. So in jar A, 150 gram we know of peanut butter costs $2.14. So here we have it. Great. So we're now trying to figure out what's the price for 1 grams.
In the small jar.
Hear me about 1 grams for 1 gram.
1 gram.
So here we have it. So the cost now is $0.014, correct to 3 decimal places. That's the price for 1 of the gram in the 150 gram the jar.
Cheap, man.
Wait, no, man. Let's look again.
Yeah, buy 5 grams.
Let's talk about the jar B now.
Okay.
Which was the 400 gram,
Right, which
right?
is a bigger jar.
Great.
Right,
So we're doing the same process now. We need to figure out what's
How
the
much
price
per gram.
per gram of this one,
Okay.
which is $0.016.
Look at that. And I
Correct
thought
to
I'd be
3
getting a
decimal
deal.
places. You think? So guess what? You're going to have to look closely now.
Yes.
To tell me now, because you would have shared all of this with us. So
That's
look
it.
closely now to tell us which one would you work with, jar A or jar B?
Well, jar A would definitely be the better buy.
Great.
Because you're paying less per gram.
Nice, great. And we're seeing it here too.
Most
That
definitely.
jar A, which was our $0.014, is definitely less than our $0.016. And if Joel thinks that the better means costing less than buying the peanut, then buying the peanut butter in jar A is definitely a better buy than
yes.
buying the peanut butter in jar B. And guess what too? Just like what you said, you would have bought more of the small one.
Right, because if I bought 3 of the small jars, $2.14 for one, that is what, $6, 4, 2 is 12. That's 52?
Somewhere along that line.
It's still, I'd get 450 grams, which would still work out
to be
way
more
better.
than the large jar, than jar
Yes,
B.
man. Jar B really tricked me this time. I thought jar B would be bigger. The money never looked too far off. But I have to really work this thing out.
Yes, because bigger does not mean it is always the best
And the
buy or the
estimation thing
better
not
buy.
necessarily get me
Great.
the right solution.
So what did you use then? How you tried to figure out this solution? How?
Well, it's really reasoning, because I had to figure out that it's really logical reasoning, because I had to look at how am I going to compare these 2 jars of the same brand of peanut butter. I'm going to have to break it down and figure out how much 1 gram cost, which I really had to reason that out. So I would say logical reasoning.
And you're right
go.
on spot. So it's logical reasoning. And this is an important tool in mathematics. Wherever problem solving is, it's an important tool because it helps students to develop a deep appreciation for what they are doing. And guess what too? Logical reasoning consists of some stuff.
And in order for us to understand that problem, there had to be some reasoning there.
Yes.
Because just looking at the 2 jars of peanut butter would not give us sufficient information to understand and make any sort of plan.
Because we would readily run and buy the larger one to say, oh yes, we're getting, oh yes, it's bigger enough, so we're getting the better buy. No. We have to reason it out. And logical reasoning involves a lot of things.
Yes, it does. Examining the problem to determine what information has been provided. Asking asking the right questions to determine what other information is needed. And last, using the information given as well as the answers obtained to make inferences and draw conclusions.
So we would have,
reasoning.
yes, logical reasoning. So we would have looked at working backwards in one of our problems, in Junior's problem.
Right, Junior and that farm.
Yes, and now Joel have his supermarket problems, and we reasoned for Joel's supermarket problem. So we got on 2 strategies.
Right,
I
so
hope we're taking note. You know, we got on 2 strategies
But
already.
we did say, that problem solving doesn't mean that you have that one plan and see that you can try different ideas. Different strategies.
Right.
Let me use the correct term. Different strategies can be applied.
And we're still linking it to our process, so we have to understand the problem.
Definitely have a plan.
You have a plan, great.
And?
Solve it.
And then?
We check.
That's right.
So that's our problem solving process. So here we have another problem.
All right.
So apart from Joel going to the supermarket, here Rowan is going to the supermarket too. And he wants to purchase rice, potatoes, and milk. He needed 6.5 kilograms of rice costing $2.40 per kilogram.
Right.
$52.80 for 4 bags of potatoes and $2.13 per carton of milk. The supermarket had various combo packages, and we can attest to that.
Yeah,
They always have them packages going on and the deals. But there was one which matched his selection. He spent a total of $92.40. The receipt was blurry, and he wanted to see all the details of the items he purchased. How could we help solve this problem now with the information given and the blurry receipt?
All right, so let me read it again because I need to understand this problem.
Good job. So right there and then you can realize too that you don't necessarily have to read the problem one time and get it. Sometimes 2, 3, 4 times you have to read it.
Right.
So go again.
So let me read. Rowan went to the supermarket. He purchased rice, potatoes, and milk. He needed 6.5 kilograms of rice, costing $2.40 per kilogram. $52.80 for 4 bags of potatoes and $2.13 per carton of milk. All right, so right away, I know he bought 3 things, 3 different items. Yeah, and I know the cost of them ish. Yes. All right, so his combo now, this combo thing. So he know his total was $92.40. That's his total.
Yes.
That's so. All right. So all right, I get information. All right. What is being asked again? How could
remember his receipt was great.
So the receipt was blurry, and he wanted to see all the details of the purchase. I'm assuming that he realized the receipt when he reached home. Come better socks and back for and print out.
Thank you very much. And that's why we need to pay attention too.
So he's at home now, and the receipt blurry. Okay. How could we solve this problem with the information given and the blurry receipt?
It could be a case too, where his wife said, "No man, I need to see how you spend $92.40 and him can't explain, so him have a problem. And he needs to fix the problem." So based on what you would have just done.
Yes, so we understand all the information that's given and what is required of us. We need to help Rowan figure out how he spent the money.
And you would have highlighted. You see, just like how we told him earlier, and understanding, even when you read it 1, 2, 3, 4 times, you can highlight, circle, underline.
Yes,
because when you would have been reading it now, you would have been saying, "Oh, I know that he needed 6.5 kilograms of
so
rice."
Just underline that with the money per kilogram.
You look at the potatoes, the milk, you know all of that, and then you would have also said to us, "Hey,
circle the total.
The total. And we look what the problem is, because we need to know what we're trying to figure out.
Right.
We know what we have, and we need to know what we are trying.
So we basically help him to replicate the receipt.
Yes, we're trying to help him to have the receipt, then to be able to look at it to know exactly how much money he spent on Maybe each item, based on what we're going to be looking at too on each item, the total cost for the item differently from the unit price as well.
Right, so we want him to pretty much be able to see what's on the receipt. So, how are we going to do that?
Yes,
Well,
how are
we
going
would
to do
love
that?
for our audience to work on this, right? Because this is important. I want them to get a chance to think about this before we even solve it here.
Right. So we'll pause here to give way to a few messages. We'll be back in just a bit. Because we have been talking about problem-solving process where we looked at understanding,
Right, man, and we went through
planning.
it. We read the problem a second time. We understood all that he bought and what he paid per kilogram for each thing that he bought. Well, except for the milk, it's per carton.
Yes, and the potatoes is bags.
Right. So we looked at the information that was given in the problem and how much the total that he had spent. All right. So we are now faced with helping him to pretty much put back that receipt together. So I think maybe we could put this information on a table, man.
We can put it in a table.
Yes, ma'am.
All right, let's try and put the information that we have now in a table.
Most definitely.
So let's see what it would look like.
All right. So we have the items, the quantity, the unit price, the total cost. Whole part information this one.
No, but this is what we would have looked at with his problem because he bought.
The receipts would I really have on all of this?
Yes, remember, you know, he bought rice,
yes,
potatoes, milk, and the quantity.
Right, and you know we have to pay tax, so tax.
Right, tax, okay. The subtotal tax, the total, and we have our total costs on the other.
Oh, so these are the things. Well. These are things he doesn't know these things. Also, we need to find W, X, and Y.
Yes, these are the things that are missing, and if him don't figure this out, and if we can't help Ron to figure this out,
might have to go back to the supermarket.
Well, I am sorry for that condition.
All right. So where do we go? Okay. So for the rice, we have the quantity and we have the unit cost. So we can figure out the total cost for the rice, man.
You're sure?
Yeah, man, we can figure it out, man.
Wait. How are we going to figure that out now?
Listen, man, if you need 6 kilogram, 6.5. Even if I don't know how to multiply, miss, I could add $2.40 6 times.
What about the half?
I would half it.
Oh, you would half it and add it to it.
Add it to it too.
All right.
Because it's half.
So we
Right.
can multiply
So I
the
can do
quantity
I
there
can multiply.
by the unit. So we
Right.
can do the repeated addition, yes. But we can go ahead then to do our 6.5 multiplied by our $2.40.
Much better.
All
Yes.
right. What about the potatoes?
All right, so 4 bags of potato cost $52.80. Simple something that, man. We divide $52.80 by 4.
No, sir.
What do you
Just
mean?
now you told us that we're going to multiply the quantity by the unit price.
but
so
you see now,
how you going to divide?
Because I don't know how much for it, so I can't take it away from it. So I have to figure out how much 1 bag costs.
Okay, so
it's
it's the
4 bags
Oh,
cost that. So I have to divide it up into 4 equal.
Oh, I get it. I
Parts.
get it. So for the potatoes, I get it. I
I just
get
have
it.
to divide.
And I can do this milk one. So
Yeah,
watch
yeah.
me now for the milk one.
Sure.
Boom, man, I just multiply. So I just say, all right, my unit price is $2.35. My total cost is $14.10. So I just multiply and I get how much cartons in buy, you know, that, just like that.
Where are you going to multiply? What are you going to multiply again?
I'm looking what you're doing in the first one. When you look at the rice, you multiply and then you go divide. So now I must multiply.
You're not. All right. Good attempt, but let's look at the first column. This is column. The first row. I have information in this column and this column. Look at yours. Even the information layout is different. So I can't use that same method that I use for the first row.
Okay, so for the milk, we have how much he actually spent.
This is your total.
Oh,
and
so
this
the
is for
total
each carton.
Okay. So now that you should answer,
Come
Mama.
on, you have this, man. You have this.
So wait there. So if I can't multiply because I don't know the quantity, and the quantity is what I need to know, but I know the unit price and I know the total cost. All right, I'm going to divide, I'm going to share it, I'm going to split it up then.
That's correct. So if you divide your $14.10 by $2.35, you definitely will get how many cartons you would have bought.
And we can help Rowan to figure out what W, which is the total cost of the rice, what X, which is the unit price of the potatoes,
right,
and what Y, which is how much cartons of milk he bought. So let's take a look because we had helped him.
Of course.
Let's look what we did.
So we multiplied $15.60.
Great. So that would have been our total cost for our rice, which again is W.
Correct.
Right. And then here for our potatoes,
we would divide $52.80 by 4, giving us $13.20. There you go.
Great, which is X.
And 6. So if you divide $2.35 into $14.10, you would get 6 cartons of milk.
And when Rowan looks at this, him can stay home now.
And him can add it up on him own now. He can check it to see if everything.
Yes, I remember we spoke about checking
there
it good. So right here we have the
figures.
Right.
It adds up and see if all things come up to $92.
Go the rice,
40 cents.
the potatoes,
the milk.
So
and then of course adding tax.
Right, to the subtotal.
Of course.
To get the total.
Most definitely. And he can check if him tax right, him can check if 12% of $82.50
is $9.90 to see. All right, it's really 12% tax I paid.
Joel wife, no need for send.
It's not Joel wife, man. This one is Rowan wife.
Oh, jeez. Joel was peanut butter. Boy,
yes,
these people
man.
just
them full of problem. I'm telling you. Junior have problem. Joel have problem. And now Rowan have problem. Them full of problem.
Rowan problem solved now.
We helping them to solve their problems. But what do you think we used to help Rowan to solve his problem? His blurry receipt problem now, because he had a problem. And we help him solve the problem and we check it. We help him now to know how to check to see if all right, what you would have figured out if it's right.
Well, when we first looked at the problem, when it was written out like that, it wasn't so easy to see how they all linked. But as soon as we dropped all that information in this table, it was so much easier to access the problem and solve.
Simpler to work it out, don't it?
Much better. So made a table.
We did make
And
a table.
sometimes, I guess we can make a list.
We can make a list and we can also make a chart too, but in this case, we looked at creating our table.
That's right.
And when this method is used, 2 key activities are usually involved. These are 1, exploring the results of simpler cases and recording the answers in a table.
2, identifying a pattern from the table that can be extended over many or any number of cases. All right.
So far, again, we're looking at
Making the
problem
table.
solving strategies, and we're looking at the process in understanding, planning, solving, checking. I'm hoping that they understand fully by the time we
just to
finish.
remind, for those who are just joining us, or for those who were there and probably a little bit distracted, just remind us how we went through 3 problems, 3 different scenarios, and we helped everyone. So we had Juno with the farm coop. We did what?
We worked backwards to arrive.
And then you had Joe with the peanut butter supermarket.
We did logical reasoning.
Excellent. And Rohan and his wife.
We did making a table.
There you go. So far we gave them
3
different strategies they can
problem
use.
solving strategies. So, you know,
Okay.
we're good to go, man. Let's, oh Lord, another problem. Today is just the day full of problems.
Look so bad though, because it was 2 lines.
All right, let's see. The difference between 2 numbers is 85. The smaller is 237. What is the larger number? So we're
right.
given 3 options. A,
Okay.
152. B, 312. C, 322.
All right. So just before we even touch this, there are problems. Several problems may exist, but some problems may be easier for, depending on your age and experience, to look at and solve. But let's say we gave this to a 10-year-old. It'd probably be a little difficult for them to, and maybe not, you never know, because it depends on their experience again.
Yes.
But let's look. There are some words that I think I'd have to understand in order to get to it. For instance, the difference.
Great.
Difference. What am I talking about?
Difference. I'm different, you're different.
Oh yeah. Yeah, that's what you're going with?
Yeah.
Math difference, math.
Oh.
Math.
All right, so when you're talking about difference in math now, and we're looking at the operation, we're looking at, subtraction.
Oh, thank you. You different, I different. Yeah.
Duh.
So difference.
Right.
So difference in math, we're talking about subtraction.
Right,
Great.
that's the operation.
So the smaller is...
The smaller number here?
Yeah, the
is
smaller is
237.
237. So that means A cannot be an option.
All right. A can be an
Because
option.
152 is not smaller than 237.
I realize that you understand the problem, and you're using what you know, and you're guessing, but continue.
That's what I'm doing, man. So what is the larger number? So clearly, them just give me 2 options for things. So since 322 is larger, I'm going to try that.
322 is larger?
Yeah.
So you're guessing.
Of course.
So how you going to check if you're right? So you guess how you're going to check? Because I want to guess and I want to say B, 312. You're saying it's C, 322. How can we figure out?
I'm going to subtract 237 from the 322.
So now that you should say a long time,
Well, how else was I going to get 85?
That's why I need to know.
So
But if a child then wants to subtract, still guessing, but wants to check if they're right. So you guess and you say C. You circle C. I guess and say B. I circle B.
But me that check it first.
You're checking it.
Me that guess and check it.
So let's check it.
Okay.
So we would definitely.
Well, I didn't. Don't say 152. Can't work.
Right. So the 152.
I would not have
out
guessed.
of it.
I would not have guessed that.
Whoops. He's out of here.
That's right.
All right. Let's look at the 300. Oh, Lord, so my answer wrong. So the 312 can't work.
Well, I did just go with the bigger number because it had a bigger number.
Oh, well, all right, fine. You get it. So our answer is definitely 322.
Right.
And it's obvious what we had used to
Guess.
figure out this one. Guess and check.
You just checked it.
Yep, and we guess, and we definitely checked it.
So that's another method.
And this method, they can use it too when they're doing the multiple choice.
Most definitely.
Yeah, man, they can use it when they're doing multiple choice questions.
Yes.
But let's
We'd like you
formalize.
not to always use guess and check though.
Which is
But when
true.
you're stuck or you have a little clue, you have idea of what the answer might be, and you're down to like 2, you may want to guess and check. But let's not guess and check all 4 options.
No, not at all. Not going to work. No. So we're formalizing the guess and check method now, and it involves selecting likely solutions.
There you go.
Which we did with the conditions in our problem, and
Exactly.
we checked to see if these solutions are correct, and we did all of that. And this approach can save time if the options to a solution are few.
There you go.
You realize that keyword?
And
few.
And if we were guessing and checking, really, we did all 3 options, but we would not have chosen 152 because they did state, the problem did state that 237 was the smaller value.
Great.
So to save on time, you would not have chosen the 152 because it is not smaller. It is not larger than the 237.
237,
Yes.
right. And you realize too that you have understood the problem that
Most
we
definitely.
had. So that is very important.
You have
the
to
understanding part, we have to definitely understand before we can do anything else. So let's take a look here now at the problem. So Kenny was squaring numbers ending in 5. And so far he has the following results. So we realize row 1 number.
15, 25, 35, 45, 55, 65, and we end at 95.
All right, and we realize number when squared.
So 25, 5 5's 25, 15, 15, 2, 25, 25, 25, 6, 25. 35 times 35 gives us 1,225.
All right.
Well, I can't help you with no more.
I get what you mean because you're reading what is in the row, you know. You're telling us, so that's fine. But guess what?
Smart I am.
I'm happy that you're reading it with understanding. So let's look at A. Explain what you notice about the result of each number square. I don't want you to tell me that when you multiply or you multiply the number by itself, you get that answer below. No.
Oh.
Look again, man, and tell me what you notice. And hold on, before you do that, I'm giving you 2 more for you to think about. So the next one is you're going to describe a relationship between the number being squared, or your face changed, so, and the digits highlighted in red in each result.
The number being squared. So you're talking about the 15 and the 2. The number being squared.
Right, which is the 15, the 25, all of those numbers being squared, right?
And the digits highlighted in red.
Great. No problem, man. And this one now. And I want you to, after you figure it, I wish the viewers were able to see your face to wonder what's happening. No, when you figure out A and B, you're going to use it to complete the table.
Let me figure out. B must figure out. Okay. Explain what you notice about the results of each squared number. All right. So
this easy, you know. It's easy, man, but I'll leave in you. I'll leave in you. Try to figure it out.
Explain what you notice about the results of each squared number. All right.
We're giving you time. Hurry up, no?
Okay, they all have 2 and 5.
All right.
They all have a 5. They all have 2 and a 5.
So they all ending.
They all have 2, 5, 25, 2, 5.
All right, good. So you're picking up something happening.
So the next one going to have 2, 5 at the end too.
So all of the others.
2, 5. 25.
How you're definitely sure that they will have 25? They'll have a 2 and they'll have a 5, 25.
Don't know.
What do you mean you don't know, but you are able to tell us?
They all have 5 in it. All the numbers have 5. So clearly we're squaring the 5.
Great. So you're what you're picking up then?
Nothing else.
You not pick up anything? All right. Not a problem. No, I want you to use. You're going to look.
This relationship you're talking about.
Yeah, man. You need to tell me the relationship. I need to hurry up and tell me the relationship too, because I give you too much time. Come on, figure it out. Figure it out. Come on. I'm sure the grade 10 student at home
I don't see no relationship. You have 1 and 5 up there. You have 15. And then you have 2.
All right, so watch this now. So you would have said the last 2 digits when you're looking at each number.
Yes.
Would have ended in 2 and 5. 25 right here, right?
Right.
But now you're looking at the 2 right here. But then when you're looking at the number up top, to be squared and the number following, what you realize about the digit in the tens column? Look and tell me. So I'm helping you, giving you a hint.
So you have
1, Ignore
okay.
this one,
So
man.
you
We're
have
just looking
one.
at.
Then you have 2.
All right, and
Then
look at
you
the
have-
relationship. Hold on. So just look at the 15, the 25, and look at the 225. So you would have already told me how you arrive at the 25 right there. But I highlighted 2. So I want you to look at what is in the tens column, great in 15 and 25, and tell me how you can get 2.
1 times 2 is 2.
All right, but watch it again. Do it now for 25 and 35 and tell me if it works.
3 times 2 is 6.
All right.
And that's a third number there.
All right.
So that must be 3 times 4 is 12.
Great.
So 5 times 4 is 20.
Good, but hold on.
And then the
Hold on, man. So you're getting it. But what you realize is happening with those numbers too. So you would have had 1. The numbers...
It's increasing by 1.
Great. Good job.
Okay.
So you realize that it's increasing.
So you have 15, so you have 10, then you have 20. Pretty much, I'm just looking at the tens place.
Yes.
So you have 1, 2, 3, 4, 5, 6,
Yes.
7.
Great.
Okay.
Yeah, man. And that is why I needed you to complete the table. So based on the relationship and the observations that you would have...
I can get this.
All right.
So this is 3 times 4 is 12. So this is the 3. 4. Oh, it says 4 fours.
4 fours, where you get 4 fours?
4. That's 3. Yes, man. So this is 1 times 2.
1 times 2 give you
2.
Good.
Look.
Right.
Okay, 2 times 3 gives me 6.
Right.
3 times 4 gives me 12.
So how would you arrive right here now? Instead of you running ahead, if you don't have a calculator and you have to work this question out without a calculator, figure it out.
All right, so you go 2 times, I'll give you that times that. So 3 times 4 is 12. So it's 4 times 5 gives me 20.
Great. And what would be your last? Remember, you have to... Great. So
it's 2025.
Good girl. What would be the next one?
Holy power can't give me.
So 2025. So when 45 is squared,
5 is 30.
Right.
And then you add the 25. So it's 3025.
All right. Let me see how you're going to do the next one now. Problem is there, but guess what?
Yeah, try to trick me, you know.
Guess what?
So 65 would not be before 95.
Hold on, man.
85 would be before it.
I'm giving your head a little break.
Yeah, man, work it out yourself.
I'm giving your head a little break.
Ah, jeez. All right. Our second break is upon us. We'll be back to wrap things up after this.
Welcome back. Let's pick up where we left off. So here we were at Kenny squared numbers ending in 5, and so far he has the following results. Now Tamika was trying to figure out, so she would have completed. She would have figured out 45 when squared, but guess what? In the event, as I was reminding her and reminding our viewers before we left and we took the break, in the event we don't have a calculator,
okay,
and we are squaring number, we need to figure out this table. So you worked out 45, you worked out 55.
I did
when
65
squared.
too.
All right, you did 65
Yes.
as well. What did you get for 65 when squared? Looking at what you have here.
Never do it.
So tell me now, man, tell me now.
Oh, so the next one would be 75. So it would be 7 multiplied by
How
Six.
you know that it would be 75? I don't have 75 in my table. I want the answer for 65 and I need the answer for 95.
Paying attention to the table, you would have added 5 to get 15. I mean 10.
Okay, 10.
10 to get 15, 10 to get 25, and you keep on adding 10.
All
But
right.
you're trying to trick me and skip out some. Right? So the next one, if I added 10 to 65, I would get 75.
Great. So we have some
Right.
numbers missing
And I have
from.
to make sure I'm paying attention to continue what I did before.
All right. So we know that that answer for 65
Would
then.
be 7 multiplied by 6. So I'm multiplying the digits in the tens place.
All right.
So 7 times 6 is 42. And then I put on the 25.
All
so
right.
4,225. You're not
Good.
tricking me.
All right. We're going to see. The next one is 95. So figure it out. Let's see if you get it. So what would you do? You say I can't trick you.
All right.
It's a pity they can't see your face, you know.
Well, the next one, if I added 10 to 95, that would be 105.
Okay, you're paying attention.
105.
So we would have had 85 missing, 95 missing, and we
then-
would have had 105.
Right. So I definitely need the number that comes after to work out the previous options.
Great.
Okay. All right. So it would be 10 multiplied by 9,
All right.
which is 90.
90. You're sure?
Yes,
You're sure
yes,
it's
yes,
90?
yes. 90. It's 90. I'm sure.
You're sure it's 90? So the answer is just 90.
90, and then I add on the 25, so it's 9,025.
All right.
I got this.
You got this. So let's check if you are indeed correct. So you would have answered A. When we examine the results so far, we see that the last 2 digits are always 2 and 5, 25. And remember, we were squaring the numbers and we were looking at numbers ending in 5.
Right.
Would have also looked, when we looked at the table, for each of the numbers being squared, the first digit is multiplied by that is 1 more. So when you would have
Right.
multiplied 1 times 2, you
2.
would have looked at your tens column there, yes, but it would have still been 1 more, because when you realize that, hey, you have 65 and I jumped to 95,
Can't work
you
it.
realize what took place. But you didn't tell me what you used to figure this one out. So after a while, it took you a while to understand the problem, you know.
Oh, of course it did.
I hope you understand the
And
problem.
it's
no?
fine. It's fine. I understood in the end.
You understand, great. So in understanding, what did you do to understand it now?
I looked for the pattern because you were trying to trick me.
No, I wasn't trying to trick you,
I
you know.
looked for the pattern. There was a pattern. There was a pattern and I saw it.
All right, you saw it. You looked at the observations that were
Look there.
taking place and you would have looked at the relationship. So this would have been your solution. So you are indeed correct.
I
And
got
you would
it.
have helped Kenny to square the numbers ending in 5. So good job, you get it. So we are hoping that our viewers at home have gotten it as well.
Yes, let me see. All of them end with 25. Yep, I did
See?
it.
So we're proving it now. So all of them ending with our
2 and
25,
5,
our
right.
25, we're realizing. And in getting the first digit here now, so it's 1 times 2, 2, 2 times 3,
6.
3 times
3 times 5,
4.
4 or 12.
So 3 times 4 is 12. But watch me, you know, 6 times 9.
6 times 7,
Okay.
42. Right.
Okay. So those two
So-
numbers there, the 75, 85 would have been missing as well as our 100.
So key point to note, pay attention to the progression. Even when you do identify a pattern, if there are missing values, you can get one that's not correct.
All right,
All
so
right.
we did look at a pattern, and it's another strategy that you can use to solve problems. The goal is to look for items or numbers that are repeated or a series of events that repeat. And guess what? We need them to try this one at home. So we're just reading it for them, and we want them to try it at home, to screenshot it now and try it at home. So Dumoy rode his bicycle to the park, and he saw a number of other persons there. Some were riding bicycles and some were riding tricycles. In total, he saw 51 wheels. 1. How many bicycles and how many tricycles were in the park? 2. What possible combinations of bicycles and tricycles were in the park? And 3. Explain why the number of bicycles in the park could not be equal to the number of tricycles. So it's important here for Dumoy to know that 51 wheels. And what we know about a bicycle?
2 wheels.
Great. What we know about a tricycle?
Usually 3 wheels.
Usually three wheels, good. So 3 wheels for a tricycle and 2 wheels for a bicycle. So those are important
and
information.
And you have to account for both tricycle and bicycle.
Great. So he needs to figure this out, and we're hoping that you would have screenshot this for you to try at home.
Yes.
All right? Now, we would have looked at some strategies so far. So we're just recapping our strategies here. Guess and check was one of them we looked at. We didn't get a chance to look at act it out, but that's another problem-solving strategy. We looked at make a table, list or chart, look for a pattern, use logical reasoning, and we work backwards. So these are problem-solving strategies. And problem-solving abilities
are connected to a number of other skills, including analytical skills, innovative and creative thinking, adaptability and flexibility, initiative, a lateral mindset, and resilience.
All right, and this is just our summary.
There is never one recipe for solving a problem. You can get better and better to solve problems, both by building up your background knowledge and by simply practicing. As you solve more problems and learn how other people solve them, you learn strategies and techniques that can be useful.
And guess what? No single strategy works every time.
Exactly. And you can struggle a little, it's okay. And that's it for today's lesson. Remember, the only way to learn math is to do math. So you can tune in to JNN at 5 p.m. for the rebroadcast in case you missed anything or need to reinforce a few things.
There's also the option of accessing this or any other lesson via the on-demand feature on One Spot Media. Tune in tomorrow for more class time. Until then, be good.
Be safe.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.